So we developed the model of the production possibilities frontier yesterday, and we looked at Tom and Jen and the value of exchange. So the production possibilities frontier is our first economic model, which is probably a little bit of an abstract term for you. I know it was for me when I was in your seats 20 plus years ago. And if we were looking at, give me a good, any good. First thing come to mind.
Grapes.
What's that?
Grapes.
Grapes and, give me another one. Grapes and pizza. All right. So we'll get to beer here shortly, but grapes and pizza, let's go with. So yesterday what we were thinking about was really the true economic problem, trying to satisfy unlimited wants with limited resources. And so it's our resource constraint that sets up the output that we consume, or produce, in this case produce, we're not looking at consumption yet, and what we shows the maximum combination of two goods an economy can produce given its available resources and technology. Shows the maximum combination of two goods an economy can produce given its available resources and technology. So in our Tom and Jen example, we just had Tom and Jen labor, is how we set up that boundary, and we kind of showed how it was bowed outward. Special reason why that. So let's put one of the key things here. The key properties is that it's bowed outward. It bows out, kind of like this. From grapes, it tends to bow outward. Some important results. And the reason we believe it bows outward is that some resources are better suited for the production of one good or the other. Some resources are better suited for the production of one good or the other. So, on our island example, who was better suited for coconut harvesting? Tom, in terms of the cost difference, in terms of his opportunity cost, and Jen was better suited for fishing, right? So that's what ended up giving us that bowed outward look to it. And the same is true here if we start thinking about grapes and pizza and the cost associated with grapes and pizza. So if we have a point here, let's call it point A, and point B, and point C. Because of that curve, the trade-offs are different moving from point to point. So if I move from point A to B, I give up a certain amount of grapes to get more pizza. As I continue to move this direction along the production possibilities frontier, from B to C, this jump of how many grapes I have to give up gets bigger. Right? So the amount of grapes is now bigger. In other words, it gets more costly. It gets more costly to produce pizza the more and more closer I get to this point where we have all pizza maxed out. Let's call it point D. So let's just say that there's 1,000 slices of pizza here and 0 grapes. What we've done is we've taken all the resources, so we've taken those, shoot, I'm not very good with grapes, you kind of threw me for a loop here. What do we do for as a grape picker? We've got some sort of weeding device, a tractor type device. What do we got? Grapes that we pick from trees, maybe some sort of picker, right? So we've got a, oh yeah, that's right. So how do you put it? Pick by hand. That's really a hand job, if you don't mind saying, right? You need gloves. All right, so we need gloves. All right, so we got these special grape gloves. I'm sure we could come up with some other things too. So imagine that we've got the last unit of grapes here and we're trying to squeeze out, what are these grape gloves good for in the form of pizza production? Nothing, for the most part, right? A little easier maybe to run this direction. As we start to move this direction and we think about the pizza oven, what good is a pizza oven in the production of grapes? Nothing. So as we start to say, you know what, let's have a pizza, that first pizza is pretty cheap in terms of the grapes that you give up, because we're going to start utilizing something like a pizza oven that was basically sitting there idle, right? And so it's real cheap. We might have to take a few people away from grape production to have them start making pizza, but we get this pizza oven, we get all these other things going, and so it's pretty cheap in terms of the number of grapes we have to give up. Starting to see that relationship there, and as we push down here, it gets more and more costly because we're taking and trying to slam resources that are maybe better suited for grape production into pizza production. So that gives us this bowed outward look. All right, so the other, I guess, piece to this puzzle that this bowed outward thing gets that I've kind of explained in one way is that it becomes more costly. So as you produce more and more of one good, you have to give up increasing amounts of the other good. So this is the law of increasing costs. All right. So we talked last time, just kind of a little refresher here. Point F, what's true about it? It's inefficient. So it's a possible production point because it lies inside the frontier, but it's inefficient. And inefficiency, we're going to define in kind of a special way. We can do better, you're right. And so we're going to define efficiency in a special way. Point B is efficient. Point A is efficient. And so what defines efficiency is that in order to get more of one good, you have to give up some of the other. So that's called production or productive efficiency. So productive efficiency means that in order to get more of one good, some of the other must be given up. So, one of the key observations here is that A, B, and C are all efficient in that sense. So all points along the production possibilities frontier even though I've been using this, I flip back and forth. I want to sometimes called production possibilities curve. So all points along the production possibilities frontier are productively efficient. They're all efficient by virtue of that. And points inside are not productively efficient. And point G, unrealistic, impossible, given our current resources and technology. So points outside are not possible. So, not possible without growth in resources or technology. The exact same things we held constant when we drew it in the first place. So that sets the stage for economic growth. How does the economy grow? How do we have more stuff to share and distribute in different ways? We have to have growth of our basic resources or growth in technology. And in doing so, the production possibilities frontier shifts out. So that growth, and one more sub-bullet in here. So increases in resources or technology shift out the production possibilities frontier. Okay. Since I heard a cry for pizza and I heard a cry for beer, we went with grapes. We're going to do just a separate example. I like grapes too. And Diet Dew is one of my favorites as well. So let's do an example here. Suppose the economy produces only two goods. Beer and pizza. I'm going to change that notation to QB and QP. Okay, so we've got quantity of beer, quantity of pizza. We're going to make a little schedule now of numbers. And one possible production point is to have 20 beers and 0 pizza. Another one is 19 and 1. 16 beers and 2. 12 and 3. 7 and 4. And finally, if we want 5 pizzas, we can't have any beer. A sad day. But those are our production possibilities. Okay, so graph it out. You graph it out on your own. Now, when you graph it, I want you to be a little careful. We'll get sloppier later, kind of like I did, but for this particular one, I want you to evenly space out your hash marks here. Let's go ahead and put quantity of beer on the vertical axis, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. I left 16 out. 13, 14, 15, 16. And then on the horizontal axis, you can do the same thing. It's no big deal if you space those out a little bit more, though. You can go 1, 2, 3, 4, 5. As long as they're evenly spaced. Okay, now plot those points. So you're going to be plotting each one of these production points. Everybody get something that looks like that? I mean, if you did it, I wanted you to do it carefully this time, so if you did it right with enough equal spacing, you should have that bowed outward look to it, right? So that's what I was trying to shoot for. And we're going to try to calculate what the costs are. So I want to think about the cost of the first pizza. So what is the opportunity cost of the first pizza? So the opportunity cost of the first pizza. What would you say the first pizza cost you? 1 beer. Good. So is 1 beer. What about the second one? The opportunity cost of the second pizza. 3. Let me make sure everybody's getting caught up here. We're getting into some good stuff. So the opportunity cost of the first pizza, 1 beer. Everybody with me on that? Can I hear yeah? Yeah. All right. Opportunity cost of the second pizza. Trace. Do I hear a yeah? Yeah. No. 4. 3, 4. So why do you say 3? Who said 3? You did? You said 3. Now, why 3?
Because you're going from 19 and 1 to 16.
Okay. So how many people were thinking 4? And why were you thinking 4?
Depends on where you start at.
Okay, depends on where you start, right? So those of you who are thinking 4, you were coming down from here to here, right? Now, in order to make that a true statement, I'd say, what is the opportunity cost of the first 2 pizzas? Sorry, I should have had that labeled. What is the opportunity cost of the first 2 pizzas? But actually, I'm not interested in that. I'm interested in just the second one. So, Mallory was right here, coming from 19. By saying that I'm looking for the second, I already have 1, so I'm actually adding the second one, which is an important concept here. So, the second pizza cost me 3 beers, assuming I already have 1. Opportunity cost of the third. If we're all tracking now. 4, right? So if I'm looking for the third, it means I already have 2 of them. So what does it take for me to get from, and I just kind of arbitrarily put some ABCs, if we kind of think back to the way we did the points, from A, B, C, D, E, F. So now moving from point C to D for the third, I have to give up 4, 16 minus 12. All right, so I go 4. The fourth pizza, 5. And the fifth pizza finally, 7. Okay. Now, what about the opportunity cost of the first beer? First beer. 1.
The very first beer.
The very first beer. Now all of a sudden our brains are having to somehow operate in reverse and turn upside down and look at this thing. What'd you say? A 7. Okay, how'd you get that? Okay, so you kind of divide it equally among these 2 points, right? So let's do a little bit different trick, because not everybody might see that one, especially when we start getting into fractions. And so I want you to put your equation goggles on. I haven't even talked about goggle theory yet, have I? So we've been, I came up with this goggle theory. There's 3 ways that we're going to view math in this class. And I know some of you aren't big fans of math, and it might be a little intimidating. I don't teach it as a real heavy math course, but at the same time, that's kind of what economics is about, is being a little more quantitative. So I'm going to ask you to put on 3 sets of goggles at different times. And we've been using some different sets already. One is your graphing goggles. And so this graph here of the production possibilities frontier is one way to view, with your goggles, the production possibilities frontier. Another way to view the math is to look at the schedule. And so I call these the schedule goggles. Pretty clever with my titles, right? And so this is another way to look at the production possibilities frontier. And yet another way that we wouldn't do with this thing is we could set it up as an equation. And so this would have some sort of y equals mx squared, and it would be kind of ugly on this particular one. But there's the equation way, the graphing way, and the schedule way are just 3 different ways to view the math. Mostly in this class, we will be looking at graphing and schedule goggles. But here's an opportunity to put on some little baby, these are like starter equation goggles actually, so nothing too big here. So, I'm sorry, give me your name again. Caleb. So Caleb kind of was looking at these numbers and saying, all right, I don't have the first beer. The first beer is right here, right? But I don't have any numbers on here that says the first beer. If I'm looking here, the first beer is trapped in this interval somewhere, right? So I have to work with the limited information that I have. And what I do know, and what Caleb knew, is that I know that over this range, I can trade 7 beers, right, for a pizza. So that is the trade-off that I can make, kind of this 1 to 7 trade-off. So putting our equation goggles on, I know that 7 beers can be traded for 1 pizza. There's the equation, kind of a simplistic one. But 7 beers equals 1 pizza over that range. But I'm not interested in the opportunity cost of the first 7 beers. I want the first beer. So how do I get a 1 over here? What's that little math trick that I can do to get a 1 over here? Divide by 7. What you do to one side of the equal sign, you got to do to the other side of the equal sign to make it fair. Voila, we got it. 1 beer is equal to 1/7 of a pizza. So the opportunity cost of the first beer is 1/7 of a pizza. Now, if you're still foggy on that, hold tight. We're going to do a few more here. So let's look at the opportunity cost of the 8th beer. Opportunity cost of the 8th beer. One what? 1 1/5? So, first step in this process, so kind of step 1, where does the marginal unit, I don't think I've ever actually taken this approach here. So, where does the marginal unit live in the schedule? Sorry, I'm getting kind of small there. Where does the marginal unit live in the schedule? So if we're looking for the 8th unit, it's right here, right? We have 7. The 8th unit is after the 7th. And so over this interval, we know that 5 can be traded for 1. So 5 beers is equal to 1 pizza. I'm not interested in 5 beers. I want the 8th, which is just 1 unit. I do my little trick here, divide by 5, divide by 5. And the 8th beer is equal to 1/5 of a pizza. Okay. How about, if we're starting to get good at this now, the opportunity cost of the 12th beer? So one thing that might be a good idea is to just kind of start filling in these trade-offs. Maybe I should have used a different color. So we go from 12 to 16 as 4, 3, 1, right? 1, 1, 1. We're doing 1 the whole time there. Now you kind of get that feel of the trade-offs that are going on as we move down the schedule, or equivalently as we move along the curve, right? So opportunity cost of the 12th beer is 1/5. Why not a 4th? I thought we were in up here. 12 is here. These two are linked. Okay, good. That's a little kind of seemingly pivotal, kind of tricky, I hate to use that word, but tricky one, because it's right on the bubble, right? 12 is right there, so you're like, well, is it this one or is it this one? But it's in the language of the marginal unit, the extra unit. If I'm looking for the 12th unit, then implicitly I already have 11. So I am clearly here on the 11th going to the 12th, from 11 to 12, so it's the same. So the 12th is the same under these circumstances here. All right, now let's fill this baby out here. So let's go to the, well, let's just do the 16th. So the 16th now is in this interval. I know that I can trade 4 beers for 1 pizza in that interval. I'm not interested in 4 beers, I just want one, specifically the 16th. 1 beer over this interval is equal to 1/4 of a pizza. All right, so then a couple more here just to complete it out. Let's jump up to the 17th. Equals 1/3. And finally, the 20th. Equals 1. We're back to that 1-to-1 trade-off. If I want that last beer, getting rid of all pizza, it's going to cost me a full pizza.
So when you're doing all of this, when you're looking at the opportunity cost of pizza, you have to look just at the first numbers, and then when you're going on to the opportunity cost of beer, you only look at the side numbers you got in.
Well, you're always looking at, I'm not sure I totally understand, but you're kind of looking at both numbers, but the trade-offs from going from one to the other. So it's helpful maybe to think about, I put these points here, they correspond to here. So it's kind of like moving from C to D, D to E, and you're thinking about the trade-offs each time. But you might get a homework or test problem that just shows you the graph. It doesn't give you this. So then you're going to have to think, oh, okay, 16 minus 12 is 4. I'm giving up 4, and I'm getting 1. Right? So you have to be able to do it graphically or possibly with a schedule of numbers. And the rise of a run, if we is the slope of it, which is something I'll bring up. In fact, since you brought it up, let's just bring it up now. So for this graph with the limited information, technically what we're doing is we're just connecting line segments to each point. And so as we found out over this interval here of 8 to 12, so from in this 7 to 12 range, so if we're moving from E to D, my question is, what's the slope of that line segment? What's the slope of the PPF between D and E? What is it? Between point D and E, what's the slope, if that's a line, by the way?
Yeah.
What is it?
It's 5.
It's 5, right? Rise over run. Good old rise over run is what I always fall back to. And depending on if we're going up or down, it actually doesn't matter. That negative sign is going to come up because it's downward sloping. So if I'm giving up a pizza, then that would be a negative run and a positive 5. Or if I was giving up a pizza, it would be a negative 5 and a positive 1. Either way, you get a slope of negative 5. Now, how does the slope of this correspond to opportunity cost? Look at these numbers. Do we see any connections?
Determines how much we're giving up of one product for the other.
And which product is it? Which one does it represent the opportunity cost of, the slope of the line?
That would be the opportunity cost of
Yes. Right? So there it is right there, 5. Now notice it's the negative business is different because when we think about it being a cost, you're giving up 5 beers, but it's the same as the slope here. So in general, the slope of the production possibilities frontier is equal to the opportunity cost of whatever you're measuring on the horizontal axis. And that's a check you might use as you're working through a problem. So let me just put that note here. That's the connection between the slope and opportunity cost. So note the opportunity cost of whatever, the opportunity cost of whatever is measured, this one's not much better, on the horizontal axis is the slope of the production possibilities frontier. Now, I can see some of you mathematically minded people squirming in your chair about that statement. It's not technically mathematically right. It would be equal to the opposite of the slope because of that sign thing. But this isn't math class, so I just want to give you that double check here on being able to think about the curvature, the slope of this thing, and the opportunity cost. That's the connection. Whatever's down here is equal to the slope of the production possibilities frontier. Now, one last little morsel that involves a golf club. You guys are probably wondering when this is going to come in handy. So the real production possibilities frontier we would think would be a nice curve. And you'll see this in your textbook and some of your problems. That's your production possibilities frontier. This little thing going on here is just kind of a figment of the fact that we have limited information. So we just got these line segments that are going through there. But we expect it to be a nice curve. And so if I'm thinking about the economy operating at point A, and I want to think about the opportunity cost of our goods, if this is, I don't know, quantity of, what? Crocs, okay. And the quantity of Toms, Crocs and Toms, okay. Then the trade-offs between the two, how do we find the opportunity cost at that point on a curve? What's the slope of a curve? How do we do that? Who remembers how to find the slope of a curve? We can't, what's that? Tangent line, tangent golf club. So if we take a tangent line and we bring it so that it's just kissing that point, it kisses at one point only, and that's the tangent line. And so the slope of the curve at that point is the slope of the line that's tangent to that point, okay, or tangent to the curve at that point. So now you're back to the rise and run. Slope is still equal the rise over the run of the tangent line. So the opportunity cost is different. Same result we got over there. And we've got a is steeper, right? So this means there's a higher cost of whatever we're measuring on the horizontal axis, Crocs. Okay? So you'll have some time to work out on the homework some of the other details and kind of reinforce what we did here. But does anybody have any general questions so far? Now, is the cost of each additional unit going up or down here? Is the cost of each additional pizza going up or down? Up. Now, is this pizza different than this pizza? Is the first pizza and the fourth pizza different? Like there's more cheese and more pepperoni and a thicker, you know, one of those little stuffed crusts full of the lummy, luscious. Are these different pizzas? Is that why this one's more costly? No, they're exactly identical. So that's one thing to bear in mind here, that this is kind of a result that's coming about because of the scarce resources that are available in society. This is a little different than what you see at the store, because normally if you go to a Sam's Club or you go to a pizza shop, if you order 5 pizzas instead of 1, do you get a cheaper price on average? Yeah, that seems like how business works once in a while. You get the volume discount. That's not what's going on here at all. This is something a little bigger going on in terms of At some point, it becomes more and more costly to produce additional units of pizza because we start slamming resources that are better suited for beer production into pizza production. Now, this isn't working though, right? These numbers are getting smaller or something, aren't they, with these fractions? Or is this working here when we flip to the other good?
Yeah.
Is it opposite result, or as we acquire more and more beer, is it getting more costly or less costly? More. Don't let these fractions fool you, right? Get out your calculator if you need to. I will tell you the truth. When I took some exams, I would take 1 divided by 4. What is that? You know, you just don't know if you're under a fraction. But it's 0.25.
That's right.
0.2, right? And this is something smaller, and this is 0.33, and finally this is 1. So these numbers are getting bigger too as we acquire more. So we got the same result going on for the other good as well. The law, that's why it's the law of increasing cost. As we start to produce more and more of one good, the amount of the other good that we have to give up gets bigger and bigger, making it more costly. Okay. So, opportunity cost. We did not define yet. We need to. One of the top 3 concepts, maybe the top. I haven't been brave enough to order these, but opportunity cost. This is, one of the top 3 in econ. This is a biggie. This is like you need to know this to pass this course type of thing. So opportunity cost is the cost of something measured in terms of what was given up to acquire an additional unit. The cost of something measured in terms of what was given up to acquire an additional unit. Now, I kind of did a little, sleight of hand. By me putting additional unit in here, I really made that a marginal cost. So note, additional means marginal by making it the additional unit. So I also want to give you an alternative, simpler definition that's maybe more broad and more general. Simply the highest valued alternative foregone. So opportunity cost can be thought of as the highest valued alternative foregone. The highest valued alternative foregone. It's what you would have done if you didn't do what you did. It's what you would have done if you didn't do what you did. That's what opportunity cost is. A theme that we will pick up on next Wednesday since we are off Monday. Have a good weekend. Make sure you get to that home.